So it's in the folder for today. It looks like this. And like I said, whatever we don't get done in class, we will be doing for homework. So just kind of keep that in mind. The first thing I want to do is just review specifically what is the quadratic formula. So if does anybody feel confident in telling me what the quadratic formula is? Just the most generic form of it?
I can try.
All right, go ahead.
X equals negative b plus minus the square root of b squared minus 4ac.
Yep.
Divided by 2a.
Nice. Good job. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Something that you're going to need to commit to memory. You're going to use it throughout today, throughout your homework, review later on this week, and then obviously on the quiz on Friday as well. So just kind of keep that in mind. All right. As we go through now and as we progress, like I said before, just to get in the habit of it, let's write it down for each question. But for today, since we have it there at the top of the page, let's just kind of keep referencing that so we can, save ourselves some time and steps with the questions. Okay. First thing we always want to make sure that we have is our equation set equal to 0. So we're going to go through everything on the first page today. In number 1, my equation set equal to 0. I can just go down and list what my A, B, and C values are. Okay. I know A is number in front of x squared, B is a number in front of x, and C is that constant term. So if I look at this particular equation, what are my A, B, and C values?
3, 5, and 1.
Good. 3, 5, and 1. Okay. I'm going to take those and plug them into my equation. So I have x equals, instead of positive 5, I'll have negative 5 plus or minus the square root of 5 squared minus 4 times A, which is 3, times C, which is 1, all over 2 times A, which is 3. Again, something else to keep in mind that your A value is not always going to be a positive 1, so just be aware of that. And a lot of times, as we progress through, we can see if we can simplify something with our denominator to finish our answer. All right, but we'll get to that in a little bit. X is going to equal negative 5 plus or minus. How does the square root simplify? So what's 5 squared going to give me?
25.
25. And then negative 4 times 3 times 1. So it's pretty much just negative 4 times 3. What's that going to give me? Negative 12. Over 2 times 3, which is 6. Everybody with me so far? Okay. The inside of my square root, I still have the negative 5 plus or minus. That's going to simplify to 13 over 6. Well, the square root of 13, is that a perfect square? Can I break that down any further?
No.
Good. No. 13 is actually a prime number, right? So it doesn't have any factors. I can't break that down any further. And that denominator of 6 doesn't really simplify with anything. There's no number outside of my square root. It doesn't simplify with negative 5 at all. So I can just leave my answer as negative 5 plus or minus square root of 13 over 6. And you saw questions like that in your homework from last night. If you can't break down the square root any further, this is how you can leave your answer and then just move on from there. Okay. Any questions about number 1? All right. Number 2, I have 4x squared plus x minus 3 equals 0. So my equation said equal to 0. I don't have to worry about that. I'm going to move on now and just list my A, B, and C values. So for number 2, what are my A, B, and C values? Good. 4, 1, and negative 3. I'll take those, plug them into my equation. I'll have negative 1 plus or minus. What goes inside my square root and in my denominator?
One squared minus 4 times 4 times negative 1.
4 times 4 times negative 3, right? 4ac, and then all over, we'll go in the denominator, Emma. 2 times 4. Good. So I have x equals negative 1 plus or minus the square root of 1 squared minus 4 times positive 4 times negative 3 over 2 times 4. How does the inside of my square root simplify? What does that become? So it's going to be 1, but not minus 48. So that's one thing that we want to be careful about. Remember, the negative 4 tags along, right? Plus 48. So that's the biggest thing that we could get tripped up on. I kind of mentioned as we went over the homework. I talked about maybe thinking about how many negatives are in there. So you know you have a negative times negative, that should give you a positive. If you just have 1 negative, it's going to be a negative number. If you have 3 negatives, it'll be a negative number. But just be careful about how those numbers in there simplify. I'm going to have 1 plus 48 over 8. Well, that's the square root of 49. What's the square root of 49?
7.
7. Any questions about how I got to that point? Okay. What do I have to do from here? So I have x equals negative 1 plus or minus 7 over 8. I don't have a square root in my answer anymore, so I can't just leave it as this. What do I need to do?
You have to split it up.
Just split it up. Good. So remember, we are doing this process to find solutions, right? And with our quadratic equations, a lot of times we're going to have 2 solutions. So I know that x equals negative 1 plus 7 over 8 is one solution. And x equals negative 1 minus 7 over 8 is going to be another solution. Okay. Well, negative 1 plus 7 is going to give me 6. 6 divided by 8. I want to simplify all of my fractions. So I'm going to get 3 over 4. And then negative 1 minus 7 is negative 8. And then negative 8 divided by 8 is going to leave me with x equals negative 1. So a couple things from that. First off, just be careful about how you simplify. The second thing, make sure that you simplify your fractions as low as they can get. So this would become 6 over 8 or 3/4. You could also leave your answer as a decimal. So 0.75 would be the decimal there. And then obviously just like make sure that you simplify all answers as far as they can get with everything. Okay. Any questions there about number 2? Number 3, what do I notice that's different about number 3? It's not set equal to 0. Good. So what would I have to move in order to do that? Or make it set equal to 0? Any ideas?
Do you have to move the x squared over?
So you can move the x squared over. That wouldn't really affect anything too much. What I would suggest doing, just because as you progress through, a lot of times you want that x squared, that highest exponent term, to be positive. So I might move the 6x and the 1 over instead. And I'm left with x squared minus 6x plus 1 equals 0. Either way, it's going to work out. But just to get in the habit of making sure that that highest exponent's positive, we'll leave it like this. Okay. I have everything set equal to 0. What are my A, B, and C values? One, -6, and 1. Does anybody feel confident telling me what the next line should be? So after I plug in all my values, what should it look like?
Hey, this is Stackhouse. I have
Yeah.
a question.
What's up?
So for the b, it says -6, but for the equation, it already says negative b. So would I just become a positive or no?
Yeah, it becomes a positive 6. So essentially that negative b in the front, you're just taking the opposite sign of whatever your b value is. So you're right. It would be -6 or just +6. Okay. You can think about it as you're multiplying whatever that b value is by -1. So the sign's going to change, but the value itself won't. So you're right. It'll be +6 plus or minus. What should the rest of the equation look like? Four times 1 times 1 all over 2 times 1. Good. So 6 plus or minus -6 squared. So now be careful about the difference there. Inside the parentheses, you still carry that negative along. So the only thing that changes is what's on the outside of the square root. But when it's inside the square root, it's still going to be a -6. But you're right. So this is what we get. How does the inside of my parentheses simplify? What's -6 squared?
Positive 36.
Positive 36. And 36 minus 4, this is going to give me 6 plus or minus square root of 32 over 2. Anybody have any questions up until this point about how we got to this stopping place here? Okay. Now, one thing that we want to notice is that I can break down the square root of 32 a little bit further. Okay, so we need to make sure that we can simplify, or that we simplify when we can. Number 1, I was left with a square root of 13. That's prime. I couldn't simplify it. Number 2, I had a perfect square, which is nice, and I can simplify that further. Here we have to do a little bit more work. Square root of 32 is not a perfect square, so I know I'm not going to be left with an integer, but I'm going to have a number and then multiplying that by whatever's left inside my square root. Well, how can I break down the square root of 32? Can I break it down where maybe one of my factors is a perfect square? What are some factors of 32? Anybody have any ideas?
$16.
Good. So I have to think about how I would break down the square root and maybe think about factors of 32 where one of them's a perfect square. Notice that 16 and 2 gives me 32. And then 16 breaks down into 4 and 4. So I'm going to be left with x equals 6 plus or minus 4 root 2, because the number that has the pair goes on the outside, over 2. And then I would argue that you can simplify this even a little bit further. Does anybody know how this would simplify? What can
Can't
I
you
do?
divide it by 2?
Exactly. I have the 2 in the denominator. If I can, so again, let's think back to what number 1 gave us. I had the 6 in the denominator. I couldn't simplify it with anything up top. In number 3, I have the 2 in the denominator. It's going to simplify with that 6 and the 4. Be careful about not making sure you simplify with anything inside the square root. That's always going to stay by itself. So I'll have x equals 6 plus or minus, or excuse me, 6 divided by 2 gives me 3, plus or minus 4 divided by 2 gives me 2. The root 2 stays the same, and that's my final answer. All right, so simplify as far as you can. It's okay to leave square roots in your answer, but make sure that you can simplify them and break them down whenever you can. All right. Any questions about number 3?
Did you use the 2 and divide it?
Exactly. So if your denominator, if you can simplify in the numerator by whatever's being divided in the denominator, you can do that. So you took the 6 divided by the 2, you took the 4 divided by the 2, and that's how you got the final answer here of 3 plus or minus 2 root 2. It's not always going to be the case. We saw that in example 1. But if you can divide through, make sure you do that. Sometimes you're going to divide through and you might still have a denominator. Like there was a homework example where you could have divided all of them by 2, I believe, but you were still left with like a 6 in the denominator. Okay, so it's just a matter of how it simplifies. But if you can do that, make sure that you go ahead and do that.
That makes sense.
Cool. Any other questions? All right. We're going to jump down to 5 and 6. All right. And then we're going to talk about what the homework is after that. All right. So for number 5, what's the first thing I want to do in number 5? Very similar to what we did in number 3.
Put the 8x minus 6 and put it over.
Right. Move the 8x, excuse me, 8x and the 6 over. So I subtract 8x, add 6. I have 2x squared minus 8x plus 6 equals 0. Right. I have to make sure my equation is set equal to 0 before I do anything. List my A, B, and C values. What are A, B, and C?
2, 8, and 2, negative 8, and 6.
Good. 2, negative 8, and 6. When I plug those values into my equation, what's it going to look like here? What's my next line going to be?
It's definitely positive 8. I know that.
So positive 8 plus or minus.
Negative 8
Hold on.
squared.
Sorry. I got too many people talking. It says Emma in here is actually answering. Sorry. So you have negative 8 squared, right? And you said times 2 times 6 over 2 times 2. Good. All right, cool. I appreciate everybody participating, but couldn't hear either of you. So -8 squared minus 4 times 2 times 6 all over 2 times 2. How does the square root simplify? So I have the 8 plus or minus on the outside. What's the -8 squared going to give me? What's -8 times -8? 64. What's -4 times 2? And what's -8 times 6? -48. Good. Nice job. All over 2 times 2, which is just 4. Any questions so far about how we got to this point? Okay. What is 64 minus 48? And what's the square root of 16? Four. So you have 64 minus 48, that gives you the square root of 16. And then the square root of 16 is 4, so you have 8 plus or minus 4 over 4. What do I have to do from this point? Because now I've gotten rid of my square roots, right? Well, not necessarily cancel out. Think back to what we did. If you look back in your notes there to number 2. When I broke it down, I just had integers left over, right? I got the square root out of the way. What did I have to do?
Can't you simplify this?
So it's not necessarily thinking about anything like dividing, but remember, when we get down to the two integers, we break it up into, because we had that plus and minus up top, right? I'm trying to find each of those solutions. So I have to do 8 plus 4 over 4 and 8 minus 4 over 4. Because there's no square root. Exactly. Yeah, there's nothing up top that you can, because in that, you're just worried about simplifying. Here, we're actually trying to find a solution. So we have to still think about doing like what's in our numerator first, and then dividing it through. Either way, technically you're going to get the same answer. So here, I'll show you what I mean. So if you do 8 plus 4, that's 12. 12 divided by 4 is going to give you 3. If you do 8 minus 4, that's 4. 4 divided by 4 is going to give you 1. So these are your two solutions. Now, if you got to this point and said, all right, well, let me just divide both of them by 4, you would get 2 plus or minus 1. And 2 plus 1 gives you the 3. And 2 minus 1 gives you the 1. So either way, if you just simplify it first and then add and subtract, that's fine. I like to think about it as just breaking it up so you know that you're going to find your two solutions. But however you show your work and get that final answer, so long as it's right, is fine with me. Okay? Good question, though. Any other questions about number 5? All right. Last one I want to take a look at is number 6. Now, let's just take a quick pause and talk about why we're doing what we're doing, right? Remember when I talked about quadratic formula on Friday, we said that we use this strategy when we can't factor, right? So we're not going to graph it to find our solutions, and all of our factoring methods don't work. And if you looked through 1 through 5, that would be the case, right? If you tried to take a look at that last number and factor normally, if you tried to slide and divide, it wouldn't be the correct solution. In number 6, you actually can factor though, right? So it's kind of a way for us to just review some of our other methods of finding solutions here with quadratic equations. But we also don't want to make sure we get so like rigid to constantly use the quadratic formula when maybe we can do it in a much faster and easier way. So let's think back to factoring real quick to take care of number 6. I don't have a GCF, but I do have a special pattern here. Because remember, I can break x squared up into x times x. This into, 4 down into 2 times 2. And then I want to check my middle term there. I'll have negative 2 times 2x, which is negative 4x, and that works out. So the way that I can write my answer for this is x minus 2 squared. And it's all set equal to 0, or you can think of this as x minus 2 times x minus 2 equals 0. And then to find solutions, what did I have to do with each of those factors? When I was solving by factoring, what did I have to do with each of those factors after I simplified them to find the solution? This was on the last quiz.
Set them equal to 0.
Set them equal to 0, good. So I have x minus 2 equals 0 or x just equals 2. And they're the same thing, so you don't have to do it twice. But obviously that process is a lot shorter than using the quadratic formula to help you find the same solution that you would have. If you were to use the quadratic formula, you'd still get that, just a lot less time consuming. So just make sure that you're aware of, excuse me, we use that in a situation where factoring doesn't work. In this case, it did for us, so we'll just use that. Whatever is easiest for you and how you get the final answer is fine with me. All right. Any questions about anything that we took care of today in class? Anything from this page at all? Everybody's good? All right, for homework tonight, you're working on the back. So 7 through 12. Number 7, 8, 9, and 10, it's just using the quadratic formula to help you solve. All right, make sure that you're using that. Even though I just showed an example with factoring. And then 11 and 12 are done for you. It just says to find and explain the errors in each problem. So this is a good way for you to kind of check yourself with the process, make sure that you're kind of thinking about everything through and saying, oh, well, that's where the mistake was made. Can you spot it and try and figure that out on your own? So that's for 11 and 12. But for 7, 8, 9, and 10, you are, what's it called? You're going to use the quadratic formula to find the solutions on your own, okay? If you have not done so already, make sure you take a look in the folder for today. This is in the folder, so make sure that you pull that up and use it for tonight's homework. And you see there, the assignments in the folder as well. Complete page 2 of the quadratic formula practice, 7 through 12 all right? And we'll go over that tomorrow at the start of class. Does anybody have any questions about that assignment? All right, cool. Then with that being said, we are good for today. So if you want to go ahead and sign off, you can. And I will see you all tomorrow, all right? Enjoy the rest of your day.